Hello, welcome to our class for today. For this particular lecture, we are going to be treating energy. So this is Noble My Science Tutors Online, and you are welcome to our class for today. Please, if you have not subscribed to our channel, please subscribe. Click on the notification button and then the subscribe button so that when we upload a new video, YouTube will notify you. Also, you can reach us through the WhatsApp number that is showing right on your screen. I remain Notable Michael. So for this class, I will encourage you to get your writing materials so that we can go straight to the class. Remember, we have discussed work. So for this particular class, we are going to be discussing energy. Okay, so if you are ready, let's go straight to our class. So what is energy? Energy, as you know, is defined as a capacity to do work. The capacity to do work, and it is a scalar quantity, and it has the same unit as work. It has the same unit as work, and that is the joule. That is the joule. So for energy, we have different types of energy, right? There are different forms of energy. We have mechanical energy, electrical energy, heat energy, chemical energy, sound energy, and so on as the case may be. Now, for all these energies types, they have different sources. Okay, so sources of energy, you can get energy from carbohydrates, that is like chemical energy. You get chemical energy for carbohydrate because when you consume carbohydrate food, you have more strength. The carbohydrate that you consume will be converted to chemical energy so that it will enable you to do more work. So carbohydrate is a source of energy. Then you also have energy from the sun. Okay, and that one is called solar energy. Solar energy can be used to generate electricity. It can also be used to dry wet materials. So that is energy from the sun, solar energy. Then we have energy from burning of fuels. Like you can actually get energy from burning of fuel if you burn a fuzzy and gases, the burning of coal. Can get energy, heat energy from burning of coal, heat energy from burning of fossil and for gases. You know that when you burn coal, back then in those days when you used to have a steam engines or steam train engines, you use coal to power such engines. So which means that the coal will burn to generate to heat up the steam that will generate the energy for the train to move. So you can also get energy from coal. So these are some of sources of energy. You can add some from your own understanding. You can add more to this. So these are some sources of energy. Now all these energies can also be classified as renewable energy or non-renewable energy sources. So renewable energy sources are those energy that you get from natural raw materials. Okay, so like you can get renewable energy, that is energy like from wind, from solar, from the ocean. All these are called, or they are all this type of energy are known as renewable energies. They are known as renewable energy because you get them from natural materials, natural raw materials. Okay, then you now have non-renewable energy. These are energies that can be exhausted and they require replenishment. That is energy that you can use up and then you need to replenish that energy for you to continue to have it to use. So this type of energy are derived from like some chemical changes so that you can have that energy, like when you burn petrol, right? When you burn petrol or fuel in your automobile, it helps to generate the energy that will enable your automobile to run. So when that fuel in your car tank get expires, you have to replenish it. Okay, so energy from biomass is vegetations, right? So when you burn vegetation, you can get energy. Then you can also get energy from nuclear sources. So all these types of energy are known as non-renewable energies. Then the ones from natural sources are known as renewable energy sources. So please, I want you to take note of all these. These are some kind of questions that you might be asked in your theory in physics. Okay, so this is just a brief introduction to energy. So we're going to be looking at now conservation of energy. Conservation of energy. So what is conservation of energy? When you say something is conserved, it means that thing is not wasted. So the principle of conservation of energy states that energy can neither be created nor destroyed, but can be transformed or can be converted from one form to another, right? So that is the principle of conservation of energy. And for remember, we just said that we have different types of energies, and one of them is mechanical energy. So mechanical energy is made up of kinetic energy and potential energy. Mechanical energy is made up of kinetic energy and potential energy. Okay, so what is kinetic energy? Kinetic energy is the energy that a body possesses due to motion. Energy possessed by a body due to motion is known as kinetic energy. So a body that is in motion, a body that is moving, the energy that it has is called kinetic energy. And still, the unit of energy is joule. That is what we've said before. The unit of energy is joule. Same unit with work. That's okay. And I will also say that energy is a scalar quantity, just like work. Work is also a scalar quantity because these two, energy and work, they don't have to do with direction. That's why they are scalar quantity. Okay. So for kinetic energy, for a body or for an object that has a mass m moving with velocity v, the kinetic energy is given by half mv squared. That is half the product of the mass times the square of the velocity. Half the product of the mass times the square of the velocity. Now this equation actually you might decide to, you can derive it from the third equation of motion. The third equation of motion states that v squared is equal to u squared plus 2as. So for a body that starts from rest, the initial velocity will be equals to 0. For a body that starts from rest and accelerates with acceleration e and attain this final velocity, cover the distance of s, we can write that v squared minus u squared equals to 2as. Alright, so with this we can actually make the acceleration the subject of this formula. So if we make it the subject, we'll have that v squared is equals to u squared all over 2s. So we can have this as our acceleration. Now remember that we said that force is equals to mass times acceleration. Force is equals to what? Mass times acceleration. So if you put that into this particular equation, you will now have that this equation now, force will now become to m times v squared minus u squared all over 2s. Okay, now don't forget that work, we said that work done is equals to what? It's equals to force times distance. That's the product of force and distance or displacement. So if you substitute into this equation for force, we're going to have that work done is equals to, work done will be equals to what? M times V squared minus U squared all over 2s. All this is force multiplied by s, multiplied by s. So this s will cancel this, so that we now have that work will be equals to m times v squared minus u squared all over 2. Now we said that since the body started from rest, u will be equals to 0. So if u is equals to 0, it means our work done will now be equals to what? Half mv squared. So that is just the derivation of that formula. But the most important thing is for you to know how to apply it to solve problems. Okay, so for a body that starts from with an initial velocity u and attains the final velocity v, the change in kinetic energy is equal to half mv square. This is v final velocity all over, this is initial velocity u. So change in kinetic energy is equals to this half mv square minus half mu square, and this you can also rewrite as this. Don't forget that from the third law of motion, v square minus u square is equals to 2as. So you can actually substitute that 2as, and then you have this as change in kinetic energy. Now with this, these two can cancel each other, and then you have that kinetic energy is equals to m mass times acceleration times distance. Now mass times acceleration is given to you to be force. So this gives you force times distance, and that is equals to kinetic energy. So kinetic energy is equals to work done. Is that okay? Kinetic energy is equals to work done. So these formulas, is good you understand them so that you can apply them when you want to solve any problem. Alright, so we are going straight now to solve a problem to drive home what we have discussed. Right, so these are sample questions that we can solve. Question number 1 says that a body of mass 4 kg is acted upon by a constant force of 12 Newton for 2 seconds. Calculate the kinetic energy gained by the body. Okay, so here you are given that force is equal to 12 Newton, and the time of action of the force is 2 seconds. Then you are also giving the mass of the body to be equals to 4 kg. So for you to solve this problem, you are going to consider the variables that are given to you and what you don't know, so that you can find the kinetic energy of the body. Okay, so for this particular problem, we know that force, you are going to find the acceleration first. Force equals to mass times acceleration, and so acceleration is equals to force over mass. So when you substitute this into the equation, you are going to have 12 divided by 4. Right? This is your force, and this is your mass. So that gives your acceleration to be 3 meters per second squared. Okay, so this is the first phase of this problem. Now we know that from the first equation of motion, that v is equals to u plus at. Now what we need is the v, because since the body started from rest, we have that u is equals to 0. So v is equals to acceleration, which is 3 times the time, which is 2 seconds. So v will now give us 6 meters per seconds. Right? So once you have done this, we can now find the kinetic energy. Kinetic energy is given to you to be equals to half mv squared. So you substitute into this equation to give you half times mass times velocity squared. Now your mass is 4 kg, so just change that to 4 kg. So when you do your division out, this is 2. Okay, so when you punch this out in your calculator, you're going to have that kinetic energy is equal to 72 joule. 72 joule. So this is your kinetic energy. That's your kinetic energy. So I hope this is relatively simple, and you can see the way I related force and time to get acceleration. That means force and mass to get acceleration. Then from there got the velocity and then the kinetic energy. Alright, so for the second one, an object of mass 5 kg is moving at a constant velocity of 50 meters per second. Calculate its kinetic energy. Okay, so this one is just direct because you are giving the mass and then you're also giving the velocity. So yeah, you just say kinetic energy is equals to half mass times velocity squared. So when you substitute into this equation, you're going to have half, the mass is 5 kg times velocity square, which is 15 times 15. Okay, so when you put this out in your calculator, you will have your answer. So that will give you 562.5 joules. Okay, so this one is direct and it is relatively simple. I hope you understand how we are able to solve these problems. So we're going to move now to potential energy. Okay, so we have talked about kinetic energy, and we said that kinetic energy is the energy possessed by a body due to its motion, as a result of its motion. Is that okay? Then now potential energy is the energy possessed by a body by virtue of its position. So which means that as you are seated on your chair listening to this class, what you possess is potential energy. But once you start to move, the energy that you now possess will become kinetic energy. It means that your potential energy has been converted to kinetic energy, which is the energy that you have as you are in motion. But when you are seated, the energy that you have is potential energy. So if a body of mass m is held at h meters above the ground, the potential energy possessed by the body will be equal to the weight of the body times the height. Okay, the weight of the body times the height, and weight is given by mass times acceleration due to gravity times your height. So potential energy is equals to mgh. mgh. Now remember, we talked about the principle of conservation of energy. So for conservation of mechanical energy, this can be illustrated by this simple diagram that is here. We have said that the principle of conservation of energy says that energy cannot be destroyed, but it can be converted from one form to another. So now look at this simple illustration that is here. Assuming that an object is at h, or say this is a ball, right? So this ball now is at h above the ground, and we call that at HA. Now, if this ball is released from this height, at this particular height, the energy that the ball possesses is equals to kinetic energy, potential energy. It equals to potential energy because of its position. And because the body or the ball is at rest, the velocity is equals to 0. And if velocity equals to 0, it means that kinetic energy at this point is equals to what? 0. So the object or this ball does not have kinetic energy. The kinetic energy here is equals to 0. Now when the ball starts to fall, midway in its journey, the ball is going to have the total energy of the ball, this potential energy that it had at point A, it will still have it at point B, but because the ball now has a velocity, the total energy that the ball will have will be the total, the sum of the kinetic energy and the potential energy. The sum of the kinetic energy and the potential energy. Now, just before the ball will strike the ground, just before it gets to the ground, this potential energy it had at point A, at point C, it will now be equals to the kinetic energy. It will have been converted totally to kinetic energy. Now, all that I've discussed here is what is in this particular equations here. Now, at height HA, that's at this height, at this particular height, the potential energy or the energy possessed by the ball is equals to mgha, which is this equation 1. And I said that at that particular height, kinetic energy is equals to 0. At this height, kinetic energy is equals because velocity is equals to 0. Then at hash AB, at this height, HB, the total energy that the ball possesses will be equals to the kinetic energy plus potential energy, because at this point the ball already has a velocity. The ball already has a velocity, so the total energy possessed, which is this energy, is equals to kinetic energy plus the potential energy at this particular height. Now at C, just before hitting the ground, the energy, the potential energy it had at point A will be equals to the kinetic energy. So mgha is equal to half mv squared at C. So this is the velocity at C. Vc is the velocity at C. Vc is the velocity at C. So the potential energy has been converted totally to what? To kinetic energy. Now, according to the principle of conservation of energy, we have that the potential energy at A is equal to the total energy at B and is equal to kinetic energy at C. So you can actually use this equation to solve any problem that you are given that has to do with an object that is released from height, and maybe you're finding the energy at a particular height. You can use this equation to solve for it, right? You can use any of this equation to solve for either the height or the velocity, as the case may be, for an object that is released from a particular height. So this simple diagram illustrates the change in energy as an object is falling from air until it hits the ground. This simple illustration shows the change in energy as the body falls from a particular height. Is that okay? So we are going to use what I've learned now to solve some problems. We'll use it to solve some problems. Is that okay? We'll use what I've learned now to solve some problems. So this is a question for us to look at. Sample question again. This one says that a 5 kg mass is dropped from a height of 30 meters above the ground. Determine the velocity of the mass when it is 18 meters above the ground. So you remember what we just discussed now. So now they are asking you to find the velocity of the mass when it is 18 meters above the ground. So you are going to take note that here you are giving mass to be equals to 5 kg. Then you are giving the initial height, the initial height to be equals to 30 meters. And then you are now giving the height, the velocity at the height that you are looking for the velocity I'm looking for at the particular at 18 meters. Fine. So remember that we said that at this height, 30 meters, the energy that the body will possess will be equals to the potential energy. Then at height 18 meters, the energy that will be possessed will be equals to the total energy to possess will be equals to the sum of the kinetic energy and the potential energy. So remember the equation we just wrote now. So you have that M potential energy at height 30 meters will have been at 18 meters will have been converted to the kinetic energy at that height plus the potential energy at that height at H2. So if you have this, you can easily solve for this velocity. So we have that 5, this will be 5 times 10 times 30 equals to half times mass, which is 5, times v squared is v squared plus 5 times 10 times the height, which is 18 meters. So you can actually work this out. 5 times 10 times 30 is 1500. Is 1500 is equals to half 5 v squared plus, you can work this out to 5 times 10 times 18 is equals to 900. Is equals to 900. You remember what you are looking for is velocity. Velocity. So if you subtract 900 from both sides, you are going to have, subtract 900 from both sides, you have 600. Is equals to half 5 v squared. So you work this so that you have v squared as your subject of formula. Okay, so you can cross multiply here. 2 times 600 is 1200, which will now give you 5 is equals to 5 v squared. So divide both sides by 5. If you divide both sides by 5, you are going to have that v squared is equals to 1200 divided by 5, and that gives you, this gives you 240. Now for you to remove the square, you now find the square the both sides, so that gives v is equals to square root 240, and the velocity, if you find out, you are going to have 15.5 meters squared, 5 meters per second, I mean. So this is the velocity of the body, or of the mass. This is the velocity of the mass. So you see how we're able to use that equation of conservation of energy to solve this problem, right? So you can take note of that so that you know how to apply it. Okay, the second one is find the potential energy of a body of mass 10 kg standing on a building floor 10 meters above the ground. This one is simple. Here you are giving the mass, you are giving the height. You know that G is equals to 10. So it's just for you to apply the equation to solve this problem, right? So potential energy PE is equals to mgh. So if you substitute here, you are going to have 10 times 10 times 10. Okay, so work that out, you are going to have 1000 joules. So I think this one is readily simple and easy for you to solve and comprehend. Okay, so we'll still solve more problems. I believe that the more problems you solve, the more you understand the topic. Okay, so this particular question say a 2 kg mass is dropped from a height of 12 meters height. Okay, at what height would the velocity be 5 meters per second? So if you remember, just take your mind back to the one we just solved not quite long. You can just apply the same equation to solve this problem. Okay, so for this one, you are given the mass. The mass is 2 kg. Sorry, 2 kg. Mass is 2 kg. You are given 2 kg as a mass. Then you are also given the height to be equals to 12 meters, which is the first height, high one. You are looking for the second height too, where the velocity is equals to where v will be equals to 5 meters per second. So applying that equation that we had at mgh, the potential energy, total potential energy at height 12 meters is converted to kinetic energy plus potential energy mgh2. That's okay. So this mgh1, mgh2, and for this question we're looking for h2. Okay, so just substitute the values that you have. M is 2, so we have 2 times 10 times h1, which is 12, equals to half times 2 times velocity square, which is 5 times 5, plus m, which is 2 times 10 times h2. This is what you are looking for. Okay, so if you work this out, you are going to have 2 times 10 is 20 times 12, which is 240, equals to, this will cancel out, so you have equals to 25 plus 20 h2. Alright, so take like terms. We have 240 minus 25 is equals to 20 h2. By the time you do this subtraction and then make h the subject of a formula, you're going to have that h is equals to your h will be equals to 215 all over 20. So by the time you work this out, you will have that h is equals to 10.75 meters. So this will now be the height at which the velocity will be equals to 5 meters per second. So you see, this is how to apply these formulas to use them to solve any problem. Please try your hands on more problems for more deeper understanding. We're still solving more problems. We are not done yet. We'll still solve more problems. So let's go. Okay, so this is your test your understanding page. I always like to end my class by giving you a test so that you test your understanding and then solve more problems. So please solve all these problems that are here. Solve all these problems. These are jam questions and wire questions. Just solve them. Try your hands on them. Then you can also solve more problems too from your various textbooks. Solve the problem. You can place your answer on the WhatsApp number that will be showing on your screen shortly. Right? I will look at them and then from there I can give my comments. Then you can also put your comments on the comment section, right? On the comment section of this video. Put your comment there. So thank you so much for your time. This is where we are stopping our class for today. Guys, if you have not subscribed to our channel, please, what are you waiting for? Click on the subscribe button, click on the notification button, so that whenever we upload a new video, YouTube will notify you. You can also reach us through the WhatsApp number that is showing on your screen. Right, so this is No Man Science Tutors Online. We are bringing physics class direct to your very doorstep. Thank you for your time, and we hope to see you in our next class.